We're going to take a look at that bad part that cost me an arm and a leg to have fixed on my car and see exactly why it failed.
So you guys probably remember the video from the other day where I was talking about the expensive valve that I had to replace on my car and what it cost to do. So we're not talking about that this time. We're going to talk about the valve itself and see what actually went wrong with the valve, because I didn't really do an in-depth diagnosis of the part itself. Just kind of took it apart to show you guys what was in it. So we know what's in this. We know that it's got a motor, it's got a worm gear, it's got some gears here, plastic gears here, and then there's the valve body. But how exactly does this operate? How does it signal the car as to what it's doing? We know that it signals it through the communication bus. So there's power, there's communication line, and there is a ground, right? Just 3 wires. So we know that there's an integrated circuit in here, and if we open this up, we'll see that. But I wanted to go dig a little bit deeper. So first things first, let's pull I haven't really reassembled this. It's kind of stuck it together in the way that it was. So we've got the actuator and we've got the actual valve. Let's take a look at the valve itself and see how the valve operates, just so we know how things work and how they're supposed to work and how they signal the car and why maybe there's improvements for the design, which I know won't happen, but there certainly could be improvements to the design of this. Because see, there's not really any feedback between the valve itself and the control. This is a completely separate unit from here. So how does this signal this, or how does this signal the computer that the valve is open and closed? If we look at the valve itself, if I pull the valve apart, you'll see that there's a shaft here that turns, and that when that shaft turns, it opens and closes the valve. One way for one direction, and the other way for the other. So here's the valve. If we look down into the valve, we'll see that when it turns one way, it opens the flow one direction, and then when it turns, it opens the flow the other direction and closes off the flow to the first direction. That's how it works. It turns one way, it turns like 90 degrees. There's one opening there, and there's the other opening there, right? So this makes a 90-degree turn. If we look at this, shut up, cat. If we look at the control arm here, this is the arm that controls it. You'll see that it does have a channel on here, which engages with a channel on the other side. So when the motor turns it, it has a hard stop. One way and then the other. That is how it signals. It just turns it until it stops. And then it stops the motor, and when the motor stops, it knows that the valve is open or closed. So when it cycles, it turns one way until it jams, and then it tells it to stop. So what's going to happen? What do you think is going to happen when that does it? What do you think is going to happen to the plastic gears? I think we're going to end up with a broken gear. What do you guys think? I think we're going to find a tooth that's missing off the gear. And indeed, we have a tooth. Well, it's not missing. It's not a missing tooth. But I took a very close look at this gear here, and I found that there looks to be one tooth. I'm going to get a close up here, where the tooth appears to be that it's damaged. So what will happen is when the gear is in this particular point, and I've already marked it, so we know where it is. It's where I put the little black mark. The gear can actually slip at this point. So if I pull the motor assembly out, if I turn this gear, see, I've got good, if I hold it here in place, I can turn this. But if oh, there we go. There we go. See, I can get it to slip right there. There we go. So there's the clicking sound. Anywhere else on this gear, it doesn't do it. When I took a close look, right there where the gears mesh, there's one tooth that is a little bit deformed. So if we can get a close up. This is where the power of magnification comes in handy. It's hard to see, but you will see that there's that one tooth there where I've got the black mark right there. That tooth there appears to be ever so slightly deformed right there. And I guess what happens is this is at the end of the travel. What happens is when this turns, it turns it. There's probably another tooth at the other end that's 90 degrees out that's also maybe a little bit worn. Because what it does is it turns the gear until it hits the end of its travel. When the valve body stops this from turning. Of course, the motor is going to continue to turn. It's going to continue to turn until it stops. And that's how it's detecting whether it's at one end or the other. It runs until the motor stalls. There's a Hall effect sensor here that's counting the pulses as this is a stepper motor, as the controller is telling the stepper motor turn, 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 and then when the valve hits the end of its travel, it stops it. This stops, the counting or the pulses stop, and the microcontroller knows that it's now reached the limit. It stops trying to turn the motor, and it signals back through the control bus that the valve has reached the end of its stop. So what it would do is it would try to turn it, and it will remember what state it's in. If it remembers it's in the off, if it's in the closed state, it will remember that. If it forgets that, it's going to have to cycle it one way till it hits the end of its travel and then back. And this is what happens when you turn on the car, is it tries to cycle the valve one way and the other. With the damaged gear, you get the tick, tick, tick sound as the gear's stripping, and that's how the mechanic diagnosed it. He read the code. The code told him to check the cabin heat shut-off valve, which is this one, and he went over to the valve, put his hand on it, hit the key fob, and could hear and feel this click, click, click as it was trying to cycle. That's the part that failed. Now, how could they improve this? Well, they could put metal gears in. If they put a metal gear in here, it's not going to break. They'd have to put all metal gears over, because if you just put one metal gear in, the other one's going to also start to slip on the next one. If you put a metal gear here and a metal gear here, guess what's going to happen to this one? So you'd have to put all metal gears in. And so that's one solution. The other solution would be to have a positive feedback. Have a positive feedback loop on the valve body itself. A sensor on the valve body. Even a sensor on here. Just to tell it where the end is, so that it doesn't have to hit the end of the travel by turning the, wherever I did it here. Where's that base for it? Here. Have a sensor on this piece here. On the piece, on the top body here. Have a sensor on here, be it a Hall sensor with a little magnet, or an optical sensor, or even a mechanical sensor. But if you had a sensor on here so that it didn't have to rely on turning the valve until it hit the end of its travel, had feedback to tell the system where the valve is, that would also solve the problem. You could have you don't necessarily have to have one that turns both ways either, right? You don't necessarily. You can have this valve could be turning all the way around 360 degrees. There's nothing to stop this valve from spinning forever. It'll spin forever. It'll close both of them, and then it'll open them. One opens, one side opens, then the other side opens, and then there's a position where there's both closed. Right? So the valve itself could turn down. This only turns 90 degrees. So, but the valve could turn 360 degrees. They could have a sensor on here so that it knows where the valve is as it passes that, and then count the pulses. Count the pulses off of the Hall effect sensor so they know the position. All they need to do is have a sensor that would determine where this is when it passes home. And then you wouldn't have a valve that jams. You wouldn't have to worry about running the valve to its extreme until it stops when it jams, and then detecting the Hall effect sensor not detecting rotation. You wouldn't have to do that. You could just turn it 360 degrees and have a sensor of some type. It wouldn't matter. It wouldn't even have to be in the valve body for that matter. It could be in here. But you could have a sensor that would indicate when it makes one full rotation. So then you would know what position the valve is in. And it wouldn't matter where your position was. I mean, you could key it. You could key this so that this could only go on one way, which would be another way of doing it, so that this, when it was assembled at the factory, there was a key on here so that it would know where the valve was when it was assembled, and just a sensor on this gear. That way, you wouldn't have to worry about the gears breaking, but that makes too much sense, right? That would make too much sense to do something, design something that wouldn't fail. So I would say this is an engineering fail. This part is designed to wear out and break, so you've got to bring your car back in for service. Anyway, that's my take on it. That's my engineering brain kicking in to see exactly why this failed. And now we know it failed because of a poor design due to the way that this is hitting a hard stop. Everyone knows when you do that, you're going to break something. And in this case, if we look down at the gear tooth here, it looks to be, get close up again here, we can get another shot of it, whether I can get it close up or not. But that tooth there, if we look closely at it, that tooth is certainly been stressed. That one right there. It's not broken off, but it's worn enough that it's allowing the teeth to slip. Anyway, saved by the bell. Thanks for watching.